Okay, good morning, everyone. The last thing that will take a look at in Chapter 7 is transformations of the exponential and log function for base e. You should be able to take a look at a graph and describe the transformation from the parent function. So let's take a look at the parent function. Y is equal to e raised to the x, which is graph right there. As an exponential function, the domain is all real numbers, to recall. The range, well, let's see here. I have a horizontal asymptote there for that graph at y is equal to 0, so the range would be y is greater than 0. And then my asymptote would be the line y equals 0. As y equals 0. Now let's make a transformation to that parent function. So let's say I shift the graph up 4 units. Y is equal to e raised to the x plus 4. That's graphed right here. So I shifted the graph up 4 units. The domain is still going to stay the same, so the domain will be all real numbers. The range now is going to be y is greater than 4. Okay, the y value for that transform function never goes below the line y is equal to 4, so the asymptote is y is equal to 4. And then lastly, let's take a look at this one here. Y is equal to e raised to the x minus 3. I shifted the graph from the parent function. I shifted it down 3 units, which is this graph here. As you can see, I shifted the graph down 3 units from the parent function, from that red graph, so it went down 3 units. Again, the domain is going to be all real numbers. The range now is going to be y is greater than -3. And my asymptote will be y is equal to -3. So given any exponential function base e with a transformation, you should be able to indicate what happened. Did it go up or down? And then the domain, range, and the asymptote. You should be able to describe that. Now, you should also be able to describe the y-intercept. The y-intercept is when x is equal to 0. So for y equals e raised to the x, when x is equal to 0, e raised to 0 is 1. So my y-intercept would equal 1. When I have y is equal to e raised to the x plus 4, when x is equal to 0, I have e raised to 0 plus 4, and e to the 0 is 1, and 1 plus 4 is 5. My y-intercept would be 5. And then when I have the function y is equal to e raised to the x minus 3, when e is equal to 0, I have e raised to 0 minus 3, and then e to the 0 is 1, and 1 minus 3 gives me -2. So you should be able to describe the transformations, domain, range, and asymptote, as well as indicate what the y-intercept is for those transformations. In ditto, we can do the same thing for the log function, for the inverse function, natural log. So let's take a look at this here. So I have y is equal to the natural log of x, which is graphed here. So the domain of that function would be x is greater than 0. The domain of a log function can't be equal to 0 or negative. The range is all real numbers. And I have a vertical asymptote, then x is equal to 0. For the transformation, this graph here, what did I do? I shifted the graph 3 units to the left. I shifted it 3 units to the left, as you can see, so that would be this graph here. I shifted my asymptote 3 units to the left. So my domain would now be x is greater than negative 3. Okay. Again, you can't take the log of a zero or a negative number, which means, and for that case, x can't equal negative 3 because negative 3 plus 3 would give me 0, and anything less than negative 3 would give me a negative. So my domain is x is greater than negative 3. The range is all real numbers. And then my asymptote is x is equal to negative 3. And then lastly, let's see here. I have y is equal to the natural log of x minus 3. There I shifted the graph to the right 3, so that's that graph there. I shifted the asymptote to the right 3. So here my domain would be x is greater than 3. I can't have a value of 3. 3 minus 3 is 0, and you can't take the log of 0. And you can't have something less than 3, otherwise you'll get a negative. 2 minus 3 would give you a negative 1, so x has to be greater than 3. The range is, again, all real numbers. And then my vertical asymptote is a line x is equal to 3. Okay. So for that one there, you should be able to describe the domain, the range, and the asymptotes for the inverse function of e raised to the x.